Hey guys, today we are looking at solving two linear equations in three variables. To be more precise, given these equations, we are finding the value of this expression x plus y plus z. Let me rewrite the given equation first. Call this equation number 1. Then the second one. Now to find out the value of x plus y plus z, there are two ways. One is to solve the given equations and get the value of x, y, z and then substitute those values in this expression. But that method will fail here. You know why? When you have three variables, you need three equations to get unique values for the given variables x, y, z. But in the problem given here, there are only two equations. So generally, if you have one equation less, that will lead to infinitely many solutions. You won't get a single solution. So the first method breaks here. The method of finding individually the values of x, y, z. Now the only other way which might work is by manipulating the given equations and getting to the value of x plus y plus z directly. I will show you that. But before looking at that method, even that method does not necessarily work in all cases. Since you're asked to find out the value of x plus y plus z, there is a chance of that method working. So let's explore the ways of getting to the given expression directly by manipulating these two given equations. Generally, you need to find out suitable numbers with which these equations are to be multiplied, then subtract one of the resulting equations from the other, directly get to this x plus y plus z. So let's think of some numbers with which these equations are to be multiplied. Do one thing, multiply the first equation by 2 throughout. So what do you get? 7x into 2, 14x. Similarly, plus 20y. Then 13z into 2, 26z equal to right side will be 114 multiplied by 2, which on simplification 228. Similarly, let me multiply the second equation by 3. Generally in problems of this kind, the only challenge is to identify these numbers correctly. So while multiplying the second equation by 3, you get 15x plus 7 multiplied by 3, 21y plus 9 multiplied by 3, 27 equal to 80 multiplied by 3, 240. Call this equation say 3 and this equation 4. Now do one thing. You subtract equation 3 from 4. See, 15x minus 4x is equal to x. 21y minus 20y equal to y. 27z minus 26z is equal to just z. And the right side, 240 minus 228, which is 12. So you got the value of x plus y plus z as 12. And that is the required thing. So the problem is over. Let me add a few more points regarding simultaneous linear equations. See, the general rule to get unique or single solutions of a system of linear equations is that you should have as many equations as the number of variables. For example, in the question given here, you have three variables. So we should have been given three equations so that you can solve them and get unique or single values. Unique or single values for the variables involved in the equation, which is not possible in this case because you have one equation short. You don't have three equations. You have only two equations. In that case, the question of finding the variables involved in the equations individually and uniquely is out of the question. That's a point I'm trying to make. So in such cases, to get the required expression, don't waste your time trying to find out the individual values. Instead, think of ways of manipulating the equations like we have done here and get to the expression directly, which is what I have done here. And that is the only method which might work. I hope the point is clear. And the final answer is 12 for the problem given here. If there is any point you want me to clarify about the solution given here, or if you have any questions relating to system of linear equations, please leave your remarks in the comments below. I will certainly address those issues. And if you like the solution, please hit the like button and subscribe to my channel. And also don't forget to press the bell icon so that you will be getting many more interesting videos of this kind. Thanks for watching and see you in the next video.